Okay, good morning, everybody. So I'll be talking about the data analysis and visualization using Python. So as a part of 1 week FTP, which is organized, and coming to my agenda, my contents for the day it's so simple. Where I'll be talking about theoretically for some time, and later I'll be touching upon the demo where we'll go ahead with the hands-on, right? So that hands-on will be quite interesting than only talking about the theory part, theoretical part. So as a part of just in a couple of minutes, let me directly go to which is a well-known factor. What is data? So data, it is nothing else like facts or any items, right? Whatever it is produced. So it can be a analogical, or it can be a computative, or it can be the real-time data. So that data which has been generated from to different modes in a day by day or day by day activities, right? So then later when you say that different types of data, people used to differentiate the data in the based on their own analogy or their own philosophical way, they'll divide or differentiate the data. So here is one such thing which I just quoted here, right? So it can be qualitative and quantitative. So basically when it comes to the huge amount of data which is being generated as a quantitative data, that is where your big data will come into the picture. So once after the data is generated, then where do we store? After all, we'll be using a storage medium or storage devices. One few such I have listed here. I'm not going to say what and all those things, because it's a well known for all of us being a engineering field, right? So these are the devices which the people started using to store. But the problem came into the picture. These are what storage devices, how they have to be stored. Yes, these are the devices to store the data, but how they have to be stored in a sense, that is where you say it as a database, a data warehouses, a huge data collection. You say it as a database and data warehouses. In that means, when you say the data warehouse, where there will be a huge data which is being collected and stored, maybe in a symmetric way or asymmetric way, or you say that that it can be in a structured way or unstructured way. Any of the data is being generated. So when you say that data which is generated data is being stored in a structured way or unstructured way, that's what rather than you only talk about structured way of storage. So let me more specify with respect to the unstructured data, because every day in our real life, real world, so unstructured data itself is huge than compared to your structured data or relative data or asymmetric data, right? In that means, so once the data is being stored in the data warehouses, that's where we say that part of life cycle, data life cycle. Once it is stored, what you have to use, what you have to do. So that is where basically whenever you say that data as a part of data life cycle, there are again also we say that everybody will start defining the means of data life cycle or the process of life cycle in their own way. So here is one such you say that data is created and stored, and I wish to more pressure on this part, which is using. Because as I mentioned earlier also, the data which is being generated in a real life or a day-to-day activities, it is more is of unstructured data rather than the structured data. When the data is purely unstructured data, how, when if at all if a users wanted to use it, so how can you use it? How to clean the data so that you can use it? That is where I try to define this data life cycle in the other way, like this, in this means, which is, so as usual, the data generated data is in the data warehouses. But if at all if you want to use it, that is where you need the two factor, which is data analysis and data visualization. After all, from few days you are you're all knowing about the different ways of data data visualization from past detail again and again. So let me be specific to my concept, which is the data visualization using Python, right? I'm just giving a brief overview right here. So in that means, So in that connection, however, you said the data analysis. However, I said that every day-to-day activities, especially in the internet mediums or internet sources, which is so called, you called as social media. After all, it is the internet communications or internet services. Through that, the data being generated in a day-to-day or a second by second, it will be in the millions of terabytes of data. I repeat, millions of terabytes of data being generated per second, right? So if you think of using the data storage devices earlier in the one of the previous my slide I shown you, right? The different devices which can be used to store the data. But here I'm talking about as you are generating the data, which is millions of data which is being generated per second. So you don't, I would say, even if you build the data warehouses per city, it will not be enough, right? So if you consider huge cities or metropolitan cities, even if you create one warehouses or data warehouses per city, even then it is not enough, because that's such amount of such a huge data is being generated per day, right? So that is where you want to categorize what is required and what is not required. That's where your data analysis will come to the picture. So as same as today of day to day, we will be doing, as I hope every one of us will be doing, we will be getting the thousands of mails and thousands of messages. By the end of the day, it is you need to categorize the data, what mail is required for you to keep it, otherwise you can delete it. In the same way, messages as well. So because as I mentioned, per second itself, millions of data which is being generated. So from that data, it is you need to make an analysis that what message you want to keep it, what message you want to delete. Even in WhatsApp, every day you may be getting thousands of good morning messages, good morning emojis, or it can be photos which is being shared by your own friends or fellow mates. Whether you want to store in your mobile itself or you want to delete, that you can make a decision, right? In the same way, my dear, in the same way, in the business aspect itself, or in any organizations or in any institution aspect as well, there is a necessity of analyzing the data, what is required, what is not required. Because nobody will, as I mentioned earlier also, so if you want to retain all the data, it will not be enough. If you create a separate data warehouses per city, it is not enough, because that much of huge data is being generated, and much of it is unstructured data, which is replicated data, a same copy of photo which will be circulated throughout the world. So it is a replication of same pic, same for the same data, you are wasting the memory space. So it is you need to analyze the data to increase your productivity, or to increase your outcome, to increase your business aspect or benefit, to get benefited, right? That is where this analysis came to picture, or the necessity of data analysis. So in the one such MPR has defined the meaning of the data analysis in the way that you need to clean the data off. You need to, because every day, as I mentioned, the per second, the huge amount of garbage data which is being generated, it is you need to clean it, transfer how you want, and then modeling the data and discover. Very, very important keyword here is that discover the useful information. As I mentioned, again, let me quote with respect to general example already mentioned. So every day you will be maybe getting the thousands of messages through WhatsApp or the normal text messaging services. But it is you need to decide, it is you need to make a decision that what is required for you to retain and what is not required for you to delete it off. Because in one or the other, my previous slide, I've shown you that, as a part of data life cycle, this destruction or a destroy is also plays a crucial role in your life cycle, in a data life cycle. It is not only you always create and store. How much space is required to create? If you only have the means of create and store, there is a necessity of this destroy as well, right? In that means, my dear, so there is a necessity of this data analysis is plays a more crucial role, I say here, right? But if you want to say that you want to discover the useful information, in a sense, definitely you must have extracted the required data and cleaned the data. Cleaning the data is nothing else than placing the data however you want. That's where you call it as a modeling the data. So you model the data, then you make a decision what is required for you, what is not required for you, right? That kind of decision will be made only based only after you analyze the data. That's what you make a decision, whether you want to retain, whether you want to delete, or whether you want to forward to somebody. That kind of decision making will be the last step of your data analysis, right? So that's what my first part of my presentation, which is data analysis. The second piece of my presentation is data visualization. As a part of my data analysis process, however, yes, okay, you analyze the data. That's what you said, that analyze the data is second part. However, you say that you collect from the collected data, but it has to be presented or represented to some, represented to the authorized person, right? That is where you say that generating the reports will come to the picture, which is as same as you say that data visualization, because these are the steps which are involved in the data analytics process. I hope it is well known to you all. Again and again, let me not go into that, right? So where you will be defining the problem. You will be defining the problem statement, and you will be collecting the data. That's where second step. Then you'll be cleaning the data, and you will be analyzing the data. And finally, here I'm concentrating on the last part of the, you are generating the reports however you want it, my dear. So at the end of the day, say for example, you every day in any organizations for that matter, or any business aspect. So in any institution, in any education institution, or it can be any business, anywhere for that matter, it is not that he'll be running for the charity, right? At the end of the day, he himself, or anybody for that matter, expects some benefit out of it. So if at all, if you have to get some benefit out of it, in the sense, you should have the maturity level to sit and analyze how much he is spending per day, how much he is getting back. That's what return on investment, how much he is investing, how much he is getting back. So that kind of analysis he has to make, and that he has to visualize those generated reports out of the analysis. So your visualization will places again a crucial role right after your analysis, such that how can you make your vendor, or how can you make your owner, or anybody for that matter, so that you can visualize your results and understand the system properly or easily, right? So that will come to the picture. In that means visualization places a crucial role, I say it as. So that is where visualization is where however, I said that visualization will come to the picture only after analysis. I'm talking about analysis is made. Now you are showing your results to somebody, right? You are showing your results to somebody. That results you may be showing in the form of images or diagrams. You plot some graphs and show them. So anyway, but what is the main intention of this visualization? I repeat, my dear participants. So the intention or the main goal of the data analysis is that from the huge data which is being collected, you need to make a decision what is required, what is not required. That kind of analysis has to be made. Whereas coming to the visualization, okay, once after analysis is done, then how we are going to project to somebody. That's what, how you are going to make the person to understand your results. Right? How can you, how best you can make the person to understand your results? That is where your visualization will come to the picture, right? So you may be showing through the diagrams or flow charts, or some graphs you will make, or some animations you make, and you present to them so that they can understand in a better way, right? So that's where we say that it's the effective way of communicating to the end bodies. End bodies means it is something like consumer and the producer, right? Because results are more required for both producer and also for the consumer. It is as same as every day you will get an advertisement. It is also one of the visualization media. So you are getting an advertisement of so and so company, so and so institution, so and so college, so and so brand. So those are also visualization, because he is trying to I would say for example, let me not quote with respect to X person or X university X is saying, or giving advertisement to the people saying that X, my university is ranked in the first place in India. that is what the visualization or the result is producing to the viewers. At the same time, he himself should have his own analysis and his own reports to be ready at his level. So visualization, coming to the visualization, is all means of representing the results in a proper way, but that is required for both the ends, for both consumer and the producer as well. It can be any business or any venture I talk about, so I'm just quoting the two words as consumer and the producer. So that's what my second title of my presentation, which is visualization. However, I said that when you will be presenting to somebody, you may be representing the results in the different ways. One such it can be where you'll be representing her, you will be making them to understand in a better way by representing in the means of correlation, where you may be correlating one to the other, where you will be relating the elements or items or entities and presenting to the end users so that they can understand in a better way. Otherwise, distribution or ranking, pie chart, there are a lot many things which we are going to see further, right? So okay, that was my second part of my presentation, which is data visualization. Now let me move on to the Python. So here, as again I specify, my topic is data visualization, data analysis and visualization using the Python. What is a Python? It is also again a programming language. So he is the person who is Guido van Rossum. So if you say that Guido, if you say Guido, so it's left to you. But Rossum is the person who actually invented this Python in 1980s, and is the extension of ABC programming language. And the reason why he quoted the Python, because he was very big fan of the Monty Python's Flying Circus. It's a circus. And however, it's a open source. Python is a open source, and we'll be expecting advances or upgradation of the packages in the Python and day by day. So on the current version of the Python, it is 3.9.6. So from you believe it or not, my dears, in the last year it was 3.8.3. So this year it has become 3.9.6. So such kind of advances you can keep having. And as I mentioned, it's open source, and you yourself can build a new package, and you can also deploy it so that it can be used by the public, right? So that's what a Python. If you ask me the Python applications, it will be used, or it is used well, especially right now. So everywhere we are using the Python for the different applications. So here for naming, for listing, I'm just listing out only 5 applications right here, but it is not restricted to, right? So the applications of the Python is not restricted to only these 5. Even you can, even in audio video visualization, audio video generation, there are a lot many, even in case of designing the tools. So everywhere we are using the Python nowadays. But out of all such, today in my current presentation, I would like to touch upon this application of your Python as well, right? Even though Python is used well versed everywhere in every application in the real world, but out of all those, I would like to touch upon only this: how can I make use of Python for visualizing the data in a proper way? That's where I'll be touching upon in the today's lecture, right? So when I say that yes, I'll be using the Python for today, I'll be touching upon only this data visualization purpose. So definitely I need libraries, right? So again, that's what, when I spoke about the Python, I said it is it is a open source and libraries. It has a well-versed libraries which can be befitted with any application required in the real world or real society. So those packages, you say it is a library, are the packages which is one or the other, right? One of the same. So you can say it is a library or the package, and those libraries are the packages for your sake. Let me categorize them into the 3 different types, which is libraries for statistical analysis, data visualization, and machine learning. Because I hope you will be well versed knowing about machine learning. Your artificial intelligence or your deep learning algorithms you can run better by any means of the Python libraries, right? So today I'm just categorizing those Python libraries, and representing here libraries required are libraries related to the statistical analysis, data visualization and machine learning. So when I take up the libraries related to the statistical analysis, so first of all, what is that statistical analysis? It's all matter of the data which is being generated, that how you are going to present in the means of a statistical way, right? Statistical way where somebody can understand. There should be some kind of a qualitative approach, right? Instead of only you think of quantitative approach, right? So that's where the techniques, any techniques like ML or DL learning, DL techniques, which are right, which may be incorporated right there to produce or to generate a statistical analysis. And again, libraries for statistical analysis, again, there are plenty as well, but I'm listing out the well utilized, which is Numpy, Sci-Fi, which is scientific Python, pandas, and stats models. So these are the four well used libraries for the purpose of statistical analysis. Again, if you ask me what is that, I would say what makes that Numpy in the sense, again, even though I have listed out four libraries right here, Numpy, pandas, Sci-Fi, and stats model, but it has all those libraries has their own advances. I don't say that disadvantages, I am saying that advances. So every time they incorporate the new package, a new library, so they will come up with a new applications or additional applications, right? So likewise, some Numpy, Sci-Fi, pandas, and stats model are the four major things. Today in my demo as well, I'll try to touch upon at least two for your within the given time. So I'll try to touch upon at least two of these libraries, just Numpy, pandas, Sci-Fi, and the stats model. In the same way, in the same way, Python libraries for data visualization. So again, as I mentioned earlier as well, data visualization is all about how you are going to represent the data so that you can make the person to understand the results in a better manner. So we may be representing in the means of graphs, charts, maps, anything for that matter, so, right? So that's where the data visualization and the different libraries, again, not only these four libraries are available, there are a lot many libraries are available, but here I'm just listing out Matplotlib and Seaborn, Plotly, and Bouquet. So these are the four well-versed used Python libraries for data visualization. I repeat, Matplotlib, Seaborn, Plotly, and Bouquet. So again, as usual, it has all those four packages, which has its own advances and different purposes which will be utilized. So out of this, again, as I mentioned, so I'll try to touch upon at least two, like say for example, Matplotlib and the Seaborn, which is again one more well-versed library, Python library will be utilized because when you say that Matplotlib, which only works on the specific data, whereas when it comes to the Seaborn, which works on the different formats and different data formats as well, right? So in that way, I'll try to touch upon at least two of these libraries in the today's session. The same way, finally, again, this I'll not be touching upon, but for your information, as I categorize all the Python libraries into the three categories: the Python libraries for statistical analysis, the Python libraries for the data visualization, and this is the Python libraries for machine learning. So the well-utilized it is what scikit-learn is the well-utilized. So even we have XGBoost and LE5 again will be well utilized. So these are the some of the libraries are the tools. You can say tool are the libraries which will be utilized for machine learning, right? So this is what only I was talking about the tools, right? Before I continue my talk, so if anybody has anything to ask, I can speak to you. Am I audible?
Yes, sir, you are audible.
Yeah, before I continue, so if at all 1 minute or 2 minutes, if at all anybody would like to ask me anything, so I'll try to answer. So in the chat box, I can see any questions. Okay. Yeah, this is okay. I think this is only the question I can see here. It is somebody from he's we are using Python in 1980s. So if I'm audible to this person who quoted the question right here, my dear, I would like to say what I wish to convey here is that there for invention of any technology or any programming language for that matter, there used to be separate labs. So here is there was one lab which is headed by this Rusam, and they started using the Python. So they started building the Python in 1980s. See, again, let me tell you, the Python itself, it was invented or written in the C programming language. I hope even nowadays, whatever the operating systems you made use, though earlier the operating system itself is written by using the C program. What I would like to convey, Python is all about the list of packages or set of packages, set of libraries, right? Those the day by day or year by year, when you start implementing the new package and you keep incorporating into your lab, so that is where it is been extending till now, right? If you I hope if your question is that whether the Python was used from 1980s, in the sense, obviously from that time itself. Let me tell you some example. So first they started only for the calculator operation. They built a new package only for calculator operation. When I say calculator, it's a means of only addition, subtraction, multiplication, like that. Then later, based on the requirement, they keep building the packages. That's what I said. Last year, June, it was only the version was 3.8.3. So this August, the version is 3.9.3. So you see the extension of libraries are being included into the Python is increasing like anything. It's only because of usability. Because the people are interested to use this language very well, so even the packages will also be increased. It's a packages incorporated to it will also be increased, right? In that, maybe I am trying to convey. Am I clear right here? For the question somebody posted here as am I clear? So if you're not clear, you can ask me again. No worries. Okay, so here if you ask me, other than sklearn, any other open source library available, in the sense, definitely, see, that's what I mentioned here. I just categorize the Python libraries for the three categories as data visualization and machine learning, and the first one was the statistical analysis. But it doesn't mean to say that whatever I have listed here, only they are available. There are a lot many. By the end of the session, if I get a time, so I'll definitely show that slide as well, where I have listed all the tools which are available here. For time being, I just put only few. Scalar, which is for the machine learning Python library, but it doesn't mean to say that only it is there, right? So there are a lot many packages. Yeah, could you list? Definitely, if I get time, definitely I will, because in this slide I have not included. So I'll definitely list out those tools which are available. I think only those questions till now. The rest as normal messages. Okay, fine. I can go back. I think I can go back. So before I can go back, can I ask anybody? Can you please tell me whether I'm audible? Can I proceed?
Yes, sir. Please proceed, sir. You are audible.
Yeah, thank you. So we have another 1.5 hours. So where we'll be talking about how the Python can be utilized. Again, I'll not be going in detail from the basic of Python, because I expect all people right over here are known about the Python. So I'll not be going again. But what I would like to convey here, in the sense, we'll be using the you can make use of any of the tools I said here, Numpy, SciPy. Yeah, just a minute. Yes, so as I listed here, which is Numpy, SciPy, and Pandas stat model, all these things which you can utilize. So for for the analysis purpose, not for visualization. NumPy pandas are not used for the visualization. It is for the analysis purpose, how the data can be used. So in that means today, as I mentioned, I'll also try to touch upon both NumPy and the pandas in a little way, however it is possible, right? So in that means can I also get to know, so if anybody would like to do the coding, I mean, so do the hands-on with me, if anybody is ready, so I can wait for you and keep showing you to you. Yes. If anybody is ready, I can. You can. I will take you guys with me. If not, I'll go ahead. Can I continue? Okay, fine. So as a part of first and foremost thing, as I mentioned, so as a part of a NumPy. So as I mentioned, there are you can have a data in the proper way. So which is we call it as NumPy or ND arrays. We'll be utilizing, we'll be calling them in a different ways. And NumPy, on the NumPy also there are lot of documentations which are available. You can get into that, because if I start teaching all those things right now, so again it may take a huge time, it may kill much time. So but only the thing that, so I wish to say right here that, so whenever you NumPy is a package, right? That NumPy when you'll be using, so you need to first import that NumPy package, then only you can utilize. And as I mentioned, when you'll be using the data, it should be in the array. I repeat, it should be in the array format. It should be in the array format, then only you can utilize. So in that means first if I want to touch upon the NumPy, so before that let me launch my IDE where I'll be using this or I'll be showing the implementation process. So again, you can utilize any respective IDE list, so it can be PyCharm or any other, or I can make use of a Jupyter. As I have Jupyter in my system, so I have already installed, so I can show the Jupyter. Before that, the basic basic information or basic rule or basic concern every programmer should know, that when you will be coding in the different editors, so you should maintain that CWD, which is current working directory. You once after you go to the current working directory, then only you should have a habit of that habit. Everybody should have, right? In that purpose, so in my C drive, so I have listed something which is Python examples. I will show something like, in my C drive, I have something called as a Python example, so that I will be using it as a current working directory. So inside that, let me create one folder. So this folder, let me name as 18/9/2021. So this is the folder where I'll for the today's session, I'll be using that as a current working directory. So what I'll do, I'll say cd 19. So whatever I'll be doing from now onwards, so it will be kept in that particular directory. So for that purpose, so I went to the current working directory. And as I mentioned, so I already installed the Jupyter in my system. So I'll be directly going to the, I'll be directly launching the Jupyter notebook. So if at all, if you are not installed, so if you are not installed the Jupyter notebook, how to install in the sense, so there are multiple ways where you can also install by using Anaconda, but I did not make use of any Conda tools right here. I just made use of a simple pip install a notebook. So that's how you'll be installing the notebook. Then I can launch the notebook just by using the Jupyter notebook. Just by using this Jupyter notebook, I can. Okay, so let me store it here itself. Python examples for the today's. I'll say that explanation explanation.txt. Okay, so first I'll be, as I mentioned, you can install the Jupyter notebook by using the pip install notebook, then you can launch it. So how I'll be launching right now, so I'll just make use of Jupyter notebook and enter, so where I can launch it. See, under the Jupyter also you can also make use of Jupyter labs, where if at all if you want to do more activities, so then you can also make use of Jupyter labs, but I'll be using, for time being, I'll be using a Jupyter notebook itself. It is enough for the today's session, so I thought we'll make use of Jupyter notebook. Right, so okay, this is where I have launched my Jupyter notebook, and you can see my current working directory. In my current working directory, as of now, I have only some text file, which is nothing else than the explanation. So here also it is listed only the explanation.txt. Nothing is there in this current working directory, right? So in that means itself, so you can see here in the Jupyter. So yeah, I hope it is visible to you all. So you can see here it is 8080 localhost 8888 and something called as tree, which is root directory in the current working directory, which is created. Now if I want to launch the Jupyter, so how to do it? So I'll go to the new and Python 3. I repeat, I'll go to new and Python 3. And before I continue, so I wanted to know if anybody are willing to do with me. I can take you guys, I can guide you guys. Otherwise, I can continue. Okay. Yeah. So now I have created one Jupyter notebook. So it is not yet saved. So let me save it as a lab 1. I'll just save it as lab 1. So as I just saved as lab 1. Now, as I mentioned, whenever you want to work with the Numpy, as the Numpy itself is a what we say that Numpy is a library package. So you need to import the Numpy. I repeat, first you need to import the Numpy, then only you can work with the Numpy. So how to import the Numpy in the sense, a simple command. It is import Numpy. So this again, so when you say that import Numpy, see if you don't, also I did not get any error means, so I have imported the Numpy. So with a I have imported the Numpy without any errors. Once I have imported the Numpy, then I can deal with the data. When I say that deal with the data, so how to deal with the data? In a sense, data can be in the any format. So here I can consider the data in the form of a arrays. I repeat, I can consider the data in the form of arrays, because Numpy, it is nothing else. Numpy okay, let me write that as well. Numpy is nothing else numerical Python. So it means to say that the data should be the numerical data. Okay, so because you can perform the operations on that data, it's only related to the mathematical and logical operations, or any any mathematical equations. Okay, it is, I hope you heard of Matlab. So that kind of Matlab scenario, which is used in the Python, for that we'll be using this Numpy, right? That's what I just wanted to put here. Okay, so once after, again, if you say that Numpy is, if it is not installed, say, my dear, what I'm trying to convey, as the Numpy is already installed in my laptop, so I'm not getting any error. But suppose if a Numpy is not installed, in a sense, you will get a error here. How to install then? As usual, pip install Numpy. So just by running the pip install Numpy, either you can run in the Jupyter, otherwise you can run in the command prompt, wherever you run. So it is the same, right? Because it will be stored, I would say it will be defined into your system itself, right? So you can, as I repeat, you can run in the command prompt, otherwise in the Jupyter, what you want to run. So how to install the Numpy? It is by using pip install Numpy. So okay, by using this pip install Numpy, you can download or install the Numpy, right? Once after your Numpy is installed in your system, then only you can import the Numpy and use that, right? And as I mentioned, all the data is a numerical data. After all, Numpy stands for numerical Python. So how to work with that? So how to work with that in a sense, say for example, a it's equal to numpy dot array, because I'll be representing the data in the form of an array. I'll say 1, 2, 3, 4. So here I am creating the data in the form of an array. You can say when I display the A, you can see a one-dimensional array will be displayed. Can you observe? So here it is, one-dimensional array is created. It is one-dimensional. Otherwise, if at all I have to create the two-dimensional array. So if I want to create the two-dimensional array, so I'll say that b is equal to so here I'll put one more square bracket, because multi-dimensional array, it's nothing else, multi-dimensional list or nested list, right? 5, 6, 7, 8. So that's where I'll be creating the multi-dimensional array, which is a two-dimensional. You can see there are the 2 rows and 4 columns, right? 2 rows and 4 columns which I have created. Again, why, if you ask me, this array is a method and the numpy is the package, so I'll be using the numpy dot array. So if you don't want to, if I don't want to use it as numpy dot array, then I can make use of aliasing to the package as np. If I say numpy as np, later I don't have to use as numpy. You can simply use a what? You can simply use it as a np. So let me create one more array as np dot array of first row. I'll say 1, 2, 3. Again, second, I'll say 4, 5, 6. Again, I'll say 7, 8, 9. Like this, I have created again one more multi-dimensional array, where in that multi-dimensional array, okay, right? So in that multi-dimensional array, which has the 3 rows and 3 columns, right? So likewise, you can I'm just talking about only one type of data here. Again, if you ask me, so I'm only talking about the integers. So that I'm only talking about integers right here. I'm not dealing with any other data. But so this particular way you can deal. Again, if you wish to access, so if I say c of 0, so I'll be getting the first row. When I say c of 0, 0 means first row. If I say c of 1, okay, if I say c of 1, so I'll be getting the second row. If you, so like that, I'll be getting, so if I say c of 1 and c of 1, so c11 means it is nothing else of this second row, second column, which is the element 5. Like that, you can you'll be working with the numpy, right? So that's only a means of I'm just showing that how to work with the numpy. So I'll not be going in detail right here, but I'll quickly move on to, so what if, okay, one more example let me show later before I move on. So what if I want to display some data right here? So and that data, it is available in the file. Instead of you give the data directly like this, what if I want to extract the data present in the file, in the sense for which you can make use of a pandas. As I mentioned, the pandas you can make use. For that, again, as usual, you need to import pandas as so pd. So you see, this is only the aliasing. It is not restricted, or it's not compulsory that you have to use the aliasing. This is for our understanding, because earlier also here I either use the numpy dot array or np dot array, both are same, because np is alias to the numpy. Instead of you every time you keep typing numpy, so I'll be using the np. In the same way, pandas also, right? For pandas also same way, if the pandas is also not installed in your system, then you must install by using the pip install panda, right? So if it is not installed, definitely you can't use it, right? So once after it is installed, see here I have installed in my system, so only I'm not getting any error for pandas. If a pandas is not there in my system, definitely I would get error right here for the pandas, right? So that's how we'll be okay. So by using the pandas, as I mentioned, you can import any file. So instead of you talked about only the data which is directly like this, so let me touch upon how to import the file by using the panda. So once you install, then importing the simply I'll say that opening the file. opening the file using what? Using the pandas, right? How to do it in a sense? Definitely, it is not that difficult. Won't be the thing that okay. So as I mentioned, this is what our current working directory, right? You are the file which you would like to open. I repeat, the file which you would like to open. Try to keep it in this current working directory, because like even if it can be anywhere, but that path you have to specify. So I repeat, so here once after you imported the pandas, here you have to you can open, I'll say the data is equal to pd dot, what is pd is the alias for the pandas, pd dot read csv. So this read csv is the method. Okay, read csv is the method to read the csv file. Okay, read csv is a method to read the csv file. So here I'll say sample.csv. I expect that the sample is the one of the file which is available in the folder. Which folder? It is current working directory where you are running your Jupyter now, and I am running the Jupyter in this folder. That file must also be available there itself. If not, from here you have to give the path. Okay, from here you have to provide the path, then only you can work with. So as of now, instead of I provide the path, okay, instead of I provide the path, I can keep my data or my file which I would like to open. Okay, which I would like to open. Let me keep that file in the current working directory. So here is Reva is one such file. So I'll keep inside the folder. I'll keep that in. Okay, I'll keep inside this. So you can observe this Reva is a CSV file. I hope you know that CSV file is comma separated file. Okay, comma separated values file. So now I'll say that instead of sample.csv, I'll say that Reva.csv, and I'll run it. Now I have opened it, so only. So now if I run it, you can see that this is the content present in the CSV file. Even if you want to confirm, is it the really content present in this reva.csv file, in the sense, okay, go to it and open that CSV file. Okay, if you go and open that CSV file, you can observe inside the CSV file, right? Inside the CSV file, it has the so-and-so columns, and these fields are empty, is it not? These fields are empty. It is not the one which is displayed, which is NaN, which is not available. So right, then from the 7th row onwards, it has a data. The file has a data, so which that itself is displaying, right? So again, however, I mentioned for this arrays, you will not access the specific element. You'll be using the indexing. You will be using the indexing the same way. However, here data is the pointer which is to this CSV file. You can also do data of 0. You say data of 0, which will be data of 0, which has no value, right? So this has no value, so it is not producing, right? So you can also access because it is none, so it is not producing. So let me take you to the data of 7. Data of 7. Okay, it is still, again, it has a none. Yeah, that's what key errors we are getting, because it has the none values. So there's supposed not to be a none values, because if you have a none values, in the sense, especially in the comma separated cases, right? So it's supposed not to be. If not, even then, how to access, in the sense, you can't make it. Whenever you have a none values, you can't access by using this index, but you have one method by using the head. Yeah, head. Yes. So if you give a data.head, it will print the first. It is printing all the data actually, but it is displaying only 4. If you want to see 5 rows, so you can give head of 5. If you give head of 5, you are getting 0, 1, 2, 3, 4, 5. If you give -5, you are getting with that you will be getting the last 5 as well, right? Likewise, you can fetch the respective data, right? So even if you want to know what kind of data is this, okay, instead of this head, if you give that data.info, if you give data.info, you will get what kind of data is that. See, this is what the kind of data. So user ID under the column user ID, understand, under the column user ID, so there are only 5 elements which are actually filled. Okay, which are actually filled. You can see in the right here, you can see how many rows it has actual data in the sense it has only 5 rows. Is it not? Like that. Whereas there is one column with the return date, which has no value. Where is that? Yeah, return date. See, it has no value at all. Everywhere it is none. Right? That none should not be there. And what type of data is that? Right? That data that information also you can get it by using data.info. Like that, I'm just showcasing that Numpy and the your pandas, sci-fi, all that you can make use for dealing with the data. Now let me quickly get into the next point. So once after I'm done with, I've just shown only with the how to open the data. That's it. Okay, how to deal with the data. That's it. I'm not still. I did not go to the how to perform the operations on the data. I repeat, still I did not get you into the how to perform the operations onto the data. Before that, I'll directly take you to the visualization part. So when you say the visualization part, in the sense there are different ways of visualizing. So again, as I mentioned, that there are the different tools to visualize, which is Matplotlib. There are the library packages which has Matplotlib, which I have shown, are Seaborn. You can also use. So under the Matplotlib, what are all the different graphs today I'll be talking about in the sense. First, let us go with a simple plotting. Okay. Later we'll also deal with a bar chart. I hope you know about the bar chart. So later, once after bar chart, okay, let us also touch upon histograms. Let's touch upon. We'll also see how the data, because when I was talking about the visualization, I quoted clearly that visualization is all about not doing some operation. It's all about once the results are ready, how you are going to project to the external world. I repeat, once after your results are ready, how you are going to project to the external world. That is where your visualization makes plays a crucial role. So in that means, so I'll show you how to plot the line chart. I'll say plot the line chart, bar chart, histogram. Then if possible, we'll also look into the scatter chart, right? Scatter plots. Then we'll also look into the area charts, area plot, you can also call it as, and very well utilized, which is pie chart, right? So let us touch upon each. Now, my dear, so let me, if I have to go ahead in the sense as usual. So as I said you that for using Numpy, you have to import Numpy. For using pandas, you have to import Numpys. So in the same way, for using the Matplotlib, you have to import the Matplotlib. So I'll be using import Matplotlib. See, if I say that import Matplotlib, again, as usual, it must be installed in your system, then only you can get it. Otherwise, you just make the pip install. Very simple pip install. And here, I wish to tell you something that Matplotlib is the library package which has everything in it. But today, in the today's session, I'll be using only the PyPlots, which is Python plot. Okay, as I repeat, Matplotlib, which has huge packages, but today I'll be using only the Python plots, right? Because Matplotlib is not restricted to only to the Python, right? But I'll be using only the Python plots. So what I will do in under this, I can say that import Matplotlib dot pyplot. Okay, so because I want only the pyplot, I don't need the complete packages of the Matplotlib for the today's session. And my dear, you can import the pyplot. I repeat, you can import the pyplot like this, which is matplotlib.pyplot as a PLT. PLT is what? Alias. Wherever I use NP for NumPy, PD for pandas. In the same way, I'm using PLT for a pyplot, right? So I can use it. Otherwise, other way of importing pyplot is that from Matplotlib import pyplot as PLT. Both are one and the same idea. Either you can, I repeat, you can import the pyplot which is required, pyplot which is available in the Matplotlib. You can either import the pyplot in the either of these two ways. Okay, either of these two ways you can import. Okay, now once after the Matplotlib, that pyplot is imported, then how to create the charts. See, for your simple way, so I'll simply say that plt dot plot, right? plt dot plot. Even let me shortcut this for my easiness. I'll simply say that p dot plot. P dot plot. So inside this p dot plot, if I mention, say for example, comma 2, comma 3, because wherein I'll be providing the two axis values when in order to create the line chart, is it not? 4, comma 5, comma 6. See, a plot is ready. Okay. Okay. See, this is the plot is ready, but the show is not. I did not give that. So p dot show. Right. So when I give this p dot show, see. Okay. Okay, here I did not give the, okay, I'll come to this error case later, because as I had given in the x-axis, I had given only 2 elements, and the y-axis I had given 3 elements, so I got error. Now you can see, yeah, you can observe in the x-axis, this is the first component is the x-axis, second component is the y-axis, is it not? Second component is the y-axis. So the first component 1, 2, 3, and the second component y-axis it is 4, 5, 6. Right. If you want to understand even better, I'll say 4, 5, 2, so that you may understand in a better way. See, for the first component, see, it is something like, for the 1 it is 4, right? 2 it is 5, and the x-axis 3, y-axis is 2, right? This is x-axis and this is y-axis, is it not? So that's where I'll be plotting the line chart. This is simple line chart, right? So okay, in this line chart, for your understanding, this line chart, what I will do, there are not many options. So if I keep O in this, not 0, it is O. Okay, if I keep O in this, so wherein you can see you are going to get the dots, which is the same as a scatter plot. Understand? It is the same as a scatter plot, where you are going to get the dots, the points, which is right. I hope you are getting this. This is x-axis 1, y-axis 4. This is the point. X-axis 2, y-axis 5. This is the point. X-axis 3, y-axis is 2. This is the point. That for that itself you have drawn the line. And this is the O is the one such option which is available in the line chart. There are a lot many options like this. Okay, there are a lot many options like this to draw. This just I'm showing only one option. Again, if you want me to take you in detail, so here, okay, here I don't have to use this 1, 2, 3 here itself. Instead of, before that itself, you can define x, like x as this and y as this. You can define, and here you provide as x comma y. Okay, no problem. You will get it. Is it not? You're getting, again, even if you don't want this color to be this blue, if you don't want the color to be blue, what to do? You provide the color. What do you want? Color is equal to, but the color whatever you'll be providing, okay, the color whatever you'll be providing should be based on the you can't provide us some some which is not undefined. So say for example K, there are the color codes. See, K for black. You see, when the defaultly it was blue, then I changed the color to the K. So defaultly the color code has become, the color has become black, because color code for the black is K. Like that, for every color it has a color codes which are defined. Okay, right? So this is for coloring. When if you want to have a specific color. Right? So within this plot you can provide. Then later, so okay, this graph is prepared, but it is, you not said anything, right? Even if you want me to say in the other way, like yeah, here you can also say, for example, just let me show here. You may get something. See, I'm just using the two different values and check is it possible or not, because as the x-axis and y-axis are the two different elements. This is very important. I want you to observe. Line chart, when you will be preparing, when you will be drawing the line chart, this is not possible. Where x-axis is 1, and how come y-axis can be ABC? Right? How come y-axis can be ABC? It is not possible, right? So, but this is possible in the next kind of graphs what we are going to generate. That we'll see that later. Okay, that we'll see that later. before that, if you would like to provide, say for example, any title for this, you're not given any title for this, right? If you want to provide a title for this, you can say p dot title as a sample line chart. You can provide the title like this. See, a sample line chart has become the title for. Even you can have a grid lines. Okay, even you can have so and so grid lines. Even if you want to see, you did not mention what is x-axis, what is y-axis. If you want to mention that, okay, you can go with x label. What is that x label? We have considered. See, for that, if you want to make it even specific, I'll say that a student, and this is marks for your understanding. Then only it should be meaningful, right? I'll say marks. Here I'm drawing with respect to student versus marks. I'm drawing the graph. So at that time, x is nothing as students. X label is nothing as students, whereas p dot y label is nothing as what? Marks. Right? Now I'll draw it. Yeah, y label. Yeah, y label. L. Y label. Now you can see for the x-axis is what students, whereas y-axis is what? Marks, right? So that's where you can provide the different labels for the x-axis and the y-axis, wherein you are providing the title. So all these things are just possible in case of your line chart. Then if you want me to take you to the next bar graphs, right? This is what line charts I spoke about till now. If I wish to tell you about the bar charts, okay, if you ask me when do we use the bar charts, in the sense whenever you want to plot the graphs with respect to the different kind of elements. Okay, whenever you want to plot the graphs with respect to different groups of elements. Okay, in such case we'll be using the bar charts, especially when you have a changes over the time, when you have frequent changes over time. In such case, this line chart is not effective. Line chart is not effective. So in such case, we'll go with the bar chart. How to draw that bar chart then? How to draw the bar chart? So whenever you want to draw the bar chart, the same for the same elements, right? For these elements itself. So even if you wish to see, I can also show you something here that you don't have to either. There is no constraint that in a chart there should be only one line graph. There must be multiple line graphs. What I wish to say, in the sense, if I say x is equal to something like 4, 5, 6, or yeah, I'll say 2, 4, 6, and y is equal to 3, 8, 1. Something like this, and here I can say p dot plot of x comma y, x comma y. See, like this, where I can have a multiple lines. This is what I was talking about. In a single graph, you can have a multiple line charts. It is possible, right? It is possible, but one thing is for sure: with respect to x-axis and the y-axis, that coordinate values should be perfect. What I mean to say that, in the sense, in the x-axis you give 3 values, whereas in the y-axis you give only 2 values. It's not possible. So you can't draw the graph. See, it will end up in the error because you are not provided as many as coordinate values in the y-axis. So it will end up with error. But this will be drawn because that is perfect, right? See. Yeah, see, you can observe that will be drawn because that is perfect, right? Whereas as here the number of values are not perfect, so you are not going to get, right? That coordinate values, you must be careful about it, right? Okay, next moving to the bar chart, the same values, right? The same things. I am not going to change anything. You can observe I'm not going to change anything. I'll be just changing, instead of this plot, okay, I'll be using what? Bar. I repeat, I'll be using only bar. Even I already mentioned, when do we use the bar charts? In the sense, whenever you want to group, whenever you want to draw the graph for the different groups of data, and in such case, we'll be using the bar chart. So and how to change? So no change or no other means of changing. Only change is with respect to this. Instead of plot, I'll be using the bar. You can observe. You can observe right here. There is for the first data value I gave it as bar. For the second data I gave it as plot itself. So it is still the plot, which is line plot. If I want to change both, see here itself, I hope you saw here, both can be possible at a time. It is possible, right? You can, in the single graph, you can have both the bar chart and the line chart. Now it has both are bar charts, is it not? So that in that way, bar charts can be prepared as well, right? So again, here, let me show you something which is a legend. What is that legend? In the sense you make the difference, because here you can see in the same value, the two charts are overlapped, is it not? At the value 2, the two charts are overlapped, two values are overlapped or overwritten, right? So how to differentiate what is what? So for which you'll be using the legend. If I run that, you can observe it is legend, it is not legend, it's legend. Yeah, so you can observe, okay, inside the legend you should provide what is blue and what is black. So I'll say that first value, second value, something like that. You can say anything. Now you can observe. Okay, label is provided. Okay, so it is because of the first value, whatever we have created, that is the actually parameter value, but it is not taken as a parameter value. So whenever I'll go with the actual data set, no, at that time I'll show you, because no, so whenever we give that, there should be proper meaning here. But here I'm just taking some sample values and I'm showing. So whenever we do it for the data set, which I'll be showing you, at that time I'll show you clearly. Okay, so that is where bar charts. So then later histograms. So yeah, histograms, if you ask me, even though whenever we have the bar chart, why do we want to go to the histograms? In that sense, basically this is for the qualitative elements. In such case, you want the histograms, whereas this bar chart is all about, deals about the categorical values or quantitative relative. Whenever you want to, whenever you'll be dealing with the categorical values or categorical items, in such case you'll go with the bar chart. Whenever you want to deal with the qualitative items, you'll go with the histograms. What is the difference? If you ask me, so say for example, whenever you want to deal with the GDP growth rate, okay, if you want to deal with the GDP growth rate of a country in a time basis, so then you'll go with the bar chart. I repeat, so if you want to monthly or timely, hourly, if you want to see that GDP growth rate, then you will go with the bar chart. Whereas if you want to see in that GDP growth, you want to see the age-based investment. Say for example, in the age of 30 to 40, how many members are invested in the GDP growth? Okay, in the age of 40 to 50, how many have invested in the GDP growth? Such kind of analysis can't be made in the in the bar chart. For that you have to make use of histograms itself. Okay, for that you will have to make use of histograms whenever you want to make based on the age. Okay, if you want to make based on the age, then you have to make use of histograms. That's what histograms. Then so for the histograms, what is to be changed? What is to be changed in the sense you can have a multiple data values for the histograms. So say for example ages. If I say ages, you can have different age groups. You can have 25, 25, 60, 10, 90, 40, 10, 45, anything for that matter. You can have the different ages, whereas you can have different bins, something like which are all the people who I want to keep it in which bin. I'll say 0, 10, 20, 30, 40, 50, 60, 70 and 80, something like that. Then now I can create the bin which is histogram. So for that I'll be using hist. However, for the plot and bar we have in the same way we have hist. So where I'll be having ages as the first parameter, second parameter will be bins, right? And what I am creating in the sense for which I need to mention the hist type. Hist type is equal to bar. Okay, hist type is equal to bar, where so I'll be creating the histogram t dot show. Okay. Okay, actually that like in hist type it has a where is it? Yeah, hist type spelling mistake, but it has created, right? So now you can see this is our the histogram. This is the histogram where you can see the people, like for the whatever the age duration we have given. So for that the histograms are generated. I hope you can see the slight difference between the bar chart and the histograms. I repeat, so whenever you want to, under the categorical values, if you want to take it based on the quantitative approach or quantitative items, in such case you will be going with the histograms. Next I'll go with the scatter plots, which is just like putting the dots, just scatter plots. So for the scatter plots I'll just go ahead with the the earlier data values itself. Yeah, these values itself I'll just make use, but instead of this bar I'll just scatter. Okay, I'll see, you can observe I'm not changing my anything, I'm just changing the scatter. You can observe, see this dark thing, which is dark dots, which is for the first scatter, whereas second scatter it has 3 more. So that's what a scatter plot. See, when I hope you might have heard about in the machine learning algorithms also linear regression, logistic regression, k-means algorithm. For the all those things we'll be putting the dots only, which is nothing else than your scatter plots, right? That's all. That's what a scatter plot. I repeat, whenever you want to have a correlation with 2 or more elements, either it can be 2D and the 3D. So in such case we'll be using the scatter plots. Next is what area chart. I have listed as area chart. See, area chart can also be called as, okay, area chart is also called as stack plot. Area chart is also called as a stack plot. So wherein whenever you want to have a see with respect to scatter plot, not scatter plot, stack plot. So whenever you have a different data elements to be represented in the same graph. I repeat, different data elements to be represented in the same graph. In such case you can represent, okay, you can represent in the scatter plot. Then you have pie chart. So whenever you talk about the pie chart, so it is simple, p dot pi. Okay, within that I'll say 35 or 25, because it's all about, I hope you have seen the pie chart, which is with respect to the percentages. See, like this I can have a pie chart. So this particular pie chart, it's all about the distribution. I repeat, it's all about the distribution, how much you'll be making. So then later, if you want to have the different labels for this, okay, so then you can keep these things in a separate variable. I'll say that p, say x is equal to, so this particular values, and I can put the labels. You can also have a labels as what, otherwise here itself I can provide, no issue, labels. So whereas those labels, whatever the labels you'll be providing as labels is equal to, so there are 4 elements, right? I'll say that whoever got distinction, and yeah, I'll say whoever got distinction, There is 35. Okay. Next, I'll say first class. That's the first class. Again, if I say a second class and fail, I'm just considering like this: second class and the fail. You can also keep it in the separate, variables and pass those variables, no issue, right? So if I say like this, so which are distinction? This is what distinction and fail and second class and the what first class. So this is how you can also go ahead with. Otherwise, if you want to represent them, so I can say that legend. See legend, yeah, see legend will work right here. So in such way you can provide, okay, this is what. See legend, when I give the legend, it will give me the differences. So the blue is nothing but distinction. This yellow is what? First class. Green is second class. Red is what? Fail. So likewise you can provide. That's all. So that's what a kind of awareness about the different ways of visualization. See, as I repeat, it's not only these cases. You can also use a seaborn. So you can also use seaborn, under which there are different kind of graphs. Okay, so you can also get into those as well, but it's already getting late. So quickly let me take you to the case studies. Okay, directly let me take you to the case studies. So for the case study, what I will do, okay, practical, I'll say practical case studies. See, I'll make use of one of the very well utilized case study. One of the very well utilized case study. You can download the data. You see, basically for dealing with the case studies, you have to with the data sets. So for downloading the data sets, there are different platforms. One is what CS Dojo. CS Dojo is having some some data set. Again, Kaggle. So like there are a lot many like this. There are a lot many sources from where you can download the data set. As of now, download, go to I'll say CS Dojo, cs.dojo/io, cs.io/data, because that is the data from where I'll be collecting data. Okay. I'll go to that csdojo.io/data, from where let me download this sample CSV file, and also let me download this countries. Let me download them. Download what? Sample CSV, and also this country CSV. I'm just taking an example right here. That's it. I'll just download the country's CSV file. And as I mentioned, those downloaded files on which I am going to work out. So those I should keep it in my current working directory. Where is my current working directory? It is in the C drive, Python examples. Inside that, there is something called as 1980. So I'll keep them here, which is sample data and countries. So and now let us work on this sample data first. If I want to work on this sample data, in the sense, I'll go back to this Jupyter. Okay, as of now, let me save this here, and I'll open one more Jupyter, one more page, right? Is it okay? So I'll open one more page. I'll say new notebook. I'll say lab 2. The name for this is lab 2. Till now I just gave you only the basics. I'll say lab 2. So before I continue, are there any queries? Yeah, so this legend, yes, basically legend is for differentiating the elements whenever you'll be plotting the graph. No, so in such case, I said, can you share this Jupyter notepad? Yeah, obviously we will share, no problem. First we after we do practice. Okay, now I am talking about that. Yeah. So as I mentioned, the two data files what we downloaded, this sample data and this country. These are the two files which I'm going to work on for a few minutes. So first, let us work on this sample data. But how to open that? In the sense, as I already mentioned, you need to use the pandas. I'll say pandas in order to work with the files and use the pandas as I'll say PD. PD as what? Alias. So import pandas as PD. Right. Once after I imported, now I'll open that file. I'll say pd dot read csv. I can also see whenever you press read csv, read underscore csv of what is the file name. What is the file name? It was a sample data. Is it not? Sample data is the file name. That particular file name itself you have to specify here. Sample.csv. But you should keep this in the double quotes. Single quote or double quote. Now, so if I run this, see, I have reading this. Okay, it's not CSV, it is CSV. Sorry, it is the read CSV. Right. Once after I read it, so as usual, when I display it, so I'm going to get this data. So this is what the content of that CSV file. If you want, if you want to get to know, you can open that CSV file and check it. Is it not? This is the data, whatever available in the sample data file. Right. Once after you open that, as usual, if you want to see the individual, data. See, one more thing I forgot to tell you. Whenever you will be dealing, so whenever if it say that Numpy, in the sense there is a n type, which is the what kind of d type or data type, whatever you'll be dealing with. So here also, whenever you'll be dealing with any CSV file, first before you start directly plotting the graphs or doing some operations, you should know what kind of data it has, right? In order to know about what kind of data, you can use this this type of sample underscore data, right? So otherwise you can say the simply data, because you already read that data here. No, you can simply say that data. So if you see here, type of data is nothing else data frames. Remember this, data frames, because every data element will be considered as a data frames inside this CSV file, right? So this CSV data, it is nothing else data frames. But if you take up each column separately, okay, if you take up these columns separately, you can say data dot this column name I'll give. If I give this column name, right? So if I give that column name, which will be producing only that column data, okay, only column that column data, but that column has what data? It is the integer. It has a integer data. But even though it has integer data, how it is stored? If you want to know that, in the sense, then you have to use this itself. I'll show you that. Type of data dot, you have to use this column. What is the column name you want to? Which column you want to set? Which column you want to find out? You can observe, my dear viewers, look here. See, when I gave the type of data is nothing else the file which has the complete data. It is in the form of what? Data frames. But when I find the type of each column, it is in the form of series. So what I wish to tell here, in the sense, whenever you work with the CSV files in the pandas, a complete data, obviously it is the data frames. It is the data frames, but each column, it is the series of elements, a series of items, we say. Okay, so this is very important. Whenever you want to create a new CSV file, then you have to go with creating the data frames. If you want to add only a column to that file, then you want to add what? Series. Then you'll be using the method series. That is only for an additional information I would like to say here. Again, as I mentioned, if you can use just a data to display the complete table. Okay, complete CSV file elements you can display. But if you want to find out the each columns, so in such case you can say data dot column name, that column name. So for example, this column name, right? So if I say this column name, which will again give you the complete column, right? But if I want to get a specific element, then I have to use column of 2. If I say column of 2, which has the second element, which is 0, 1, 2, so which is producing what result as 3. Result as what? 3. Like this, we can deal with the each element in the particular CSV data. right? Now directly let me show with the how to draw the graph for this. How to draw the graph for this. So before I draw the graph, what I want to do, so first I'll say x is equal to this column A. Okay, so x is equal to column A. So what I will do, x is equal to data dot column A. Okay, the x is equal to column data dot column A, and y is equal to column B, and z is equal to column C. Like this I'll store. Next I'll say as usual, I need to what? So we have only imported the pandas right here, right? We are not imported the matplotlib. So what I'll do, from matplotlib import a pyplot as p, right? So I'm also importing the matplotlib. Yeah, I'm also importing what p, which is matplotlib, which is p. So here now what I will do, p dot plot of x comma y, p dot show, right? So you can observe for the first column, first what is x? It is the first column A. What is column? What is B? It is the column B. For these two elements, okay, for these two columns, column A and the B, I'm getting this graph. Is it not? For your understanding, you can see if I show here, see, it is something like this: 0 for one for a zeroth row, which is nothing else. Column A it is 1, column B is 1. It is 1:1. X axis is 1, y axis is 1. Same way, right? So second is 2, 2 and 4. Again 3 and 9, 3 and 9, like that, right? Again, as I mentioned, so here instead of you say x comma y, okay, instead of you mention x comma y, if you mention x comma y comma o, what did I say? You will get only the dots, right? So instead of this, instead of this plot, if you use what, scatter, see what you are going to get, which is nothing else dots, which is scatter plot, is it not? Instead of that, if you use a bar, you're going to get what, bar chart. I hope you're getting. And it is not that only I'll be doing with only x and the y, which is column A and the B. You can also plot. So you can also plot for y and z. But now you see there will be two different types of graphs. X and the y, it has the bar chart, whereas y and the z, you have line chart. Okay, for your difference, I'll say p dot. One more we'll take, which is scatter. I'm just combining all three. I'll say x comma z. Right? Now you see there are three types of graphs. Is it not? There are three types of graphs, which is charts, not graphs. There are three types of charts, which is bar chart, plot chart, scatter chart, for the three combinations which we made here, right? Like that. It is not that only you work on the data what you provide. You can also work on the data of the file. Okay, so that's what that's how you can work. Again, rest of the things are the same. Like once after you plot it here, again you can provide the labels. Okay, you can provide the labels. Say for example, p dot x label. You want to give the name for the x-axis. I'll say x-axis itself. You can provide any name, right? So you can the same way p dot y label. But when I say that you can provide any name, in a sense, provide meaningful way. I'll say y-axis, right? So I can run it here. Okay, like that you can have a different case studies, and you can also have however, see this, yeah, I'm not giving any labels for that, so it is not taking at all. So if you want to provide, you need to provide those labels actually. So I'll say that one, something like that. You can provide. Again, it is saying the same values. Same values cannot be there. Okay, that's okay. So that's how you can work with the. That's how we work with the sample data. And the same way, let us take up the countries. When I take up the countries, okay, where is it? Yeah. When I take up the countries, so same way, let me read something like this C data is equal to pd dot read csv of countries dot csv. Okay, when I read this csv file, which is countries, it has this, right? So if I want to display, it is C data. If I display that C data, what I'm going to get, see like this, I have huge data. It's almost 1704 rows I have, that huge data, right? So if I want to in this on this particular data, if I want to do any kind of simple operations, for example, if I want to get the population growth in the particular country. Okay, if I want to get the population growth in the particular country, in such case, how to get, see, because this is in the Excel sheet, right? It is a CSV file. You can also work like a Excel sheet. Right now you make it for every year, again you need to sort it based on the year, and every year how much it is changing. That you can do it manually as well, but it is not the simple data, right? It is a huge data. Manually, if you sit and do it, in a sense, it will take huge time. So instead of that, by using our package, which is our visualization libraries, you can plot it. For example, as I mentioned here, it has a country. It has a country which has the different types of countries. There is an Excel sheet. Yeah, it has a country which belongs to the different countries: Afghanistan, Albania. There are a lot many. So okay, as I have downloaded this from the internet, let me check first of all whether India is there or not. Okay, so if it is there, we will work on that. Okay, IN, right? Yeah, India is there. Very good. So you can see India is there for so many years, from year so and so to the so and so. Now what we will do, I'll extract the data. With respect to India. That's what first I'm going to do. So what I'm going to do, in the sense, I'll say India is equal to this C data. This is the C data which I have created. C data of, right? C data dot country. This is the country name. Right? Country is equal to India. So I'll just extract first of all, are there any elements belongs to India or not? There are, I think there are few, for few years it has a data, is it not? It has a data. For that what I'm going to do, in the sense, for this let us plot the graph. I repeat, for this let us plot the graph. How to plot the graph for this? So it has the 3 different columns, right? It has 3 different columns. So what I'm going to do, in the sense, I'll say p dot plot of, I'll do it with this year. Okay, I'll do it with the year. So that's India dot year, comma, India dot this population. I have to use the same keyword, so I'm just copying. You should not use the different keywords. If you use the different keywords, it will throw you error. See, now you can see, you can observe, my dear. So this is the graph which is written for the India population growth from the year 1952 to the 2007. I repeat, from the 1952 till 2007, this is how the population has a growth. Population growth has happened in India. Okay, in the same way, in the chart, there must be US as well. For the US as well, if you find out, so I'll say US is equal to C data dot country is equal to, what is the name of the country which has for the United States? Is it United States? I should give the spelling, it should be clear as I mentioned. EU, right? Yeah, it has United States. So I'll take up that United States, right? So US is nothing else. For the United States, I'm printing for the United States. Now what I'll do, I'll draw the graph for the United States as well. Let us try it now. For both, let me put together in a single graph. US population versus India population. Okay, p dot show. That's how we'll be getting the analysis, right, my dear? See, can you observe? Can you observe? From 1952, so this is the Indian population is increasing like anything, but you see the US population, right? US population is not increasing drastically, but our Indian population is increasing like anything. So that's how. So again, for this itself, again you can have X label, Y label, all that. But one thing I want to put a highlight here, that you can see it is something like 1E9. The reason why I'm getting this 1E9 in the sense, because this population rate is there, no, which has a huge number. Is it not? This population number is a very huge number, because it is in the millions. So it is as same as 1 into e power 9. That's how, something like that. But instead of that, if you want to reduce that, let me represent this population in the millions, and at that time that will be reduced. Let me show you that, because this is the units in millions, right? So what I'll do, this population is there, no, that I'll say divided by 10 star 6. It is 10 power 6. It is million. 10 star 6, I'll say. Now you see that 1 e power 9 has gone. Now this unit, every unit, this 1000 is in the million, 1000 million, 800 million, right? So that's how our population curve has increased. Curve is increasing like anything for our in India compared to US. Like that comparison is made. So this data set is available in the internet, which I downloaded, and I just thought of looking after our population comparability with the other countries, wherein I'm getting this case, right? So again, let us take up the one more data set. I just wish to give the different case studies instead of you put it in the a single, right? So yeah, before I go ahead with the further, if anybody would like to ask me anything, you are welcome. Just yes, anything anybody would like to ask?
No, sir, you can continue.
Yeah, thank you, sir. And there is one question which is you are saying that, like, can you explain the setting current working directory? Current working directory you can set when you launch the Jupyter from the notepad. Basically, when you'll be launching, where you are right now. See, whenever I started my command prompt, usually it will be in the desktop of my particular users in any system whenever you launch. But in which folder you would like to work, that first you should fix up. See, right here I just made myself that inside the C drive, but it need not be always in the C drive itself. Say for example, I'll just show you one case, as in the E drive or a D drive. So if inside the D drive there is something like called as software, which is SW. So if I want to work in this folder, in the sense, what to do in the sense, I'll go to command prompt. Okay, I'll go to command prompt like this. Default it will be in the user, okay, in the public user. So I'll just cd double dot, again cd double dot, I came to C drive. Now if as I'm mentioning that, always you don't have to find fix your current working directory in the C drive itself. You can also work in the D drive. So how to tackle that, in a sense, inside the right here you just give a D colon. I repeat, earlier it was in the C drive, you just give D colon. Now it has become D drive. Is it not? So inside the D drive, to which folder I want to go? I want to go to the SW as the folder. SW. So inside the D drive, I'll say CD SW. Right? So now I'm in the directory. Which directory I'm in? Which is SW. That's how it goes on. Even when you'll be working inside in the command prompt also, see, Jupyter notebook, it is for your for us, it will be easy for me to go up and down and show the previous results, for which I'll be using Jupyter. But you don't have to make use of Jupyter. You can run everything in the command prompt itself. As if I just type Python, so this is what the shell mode of your command prompt, where you can work right here. Even this is where you want to I mean, say there are different. That's what I said at the beginning. It's there are different ways of where you can run your Python. You don't have to use Jupyter or PyCharm, or it can be command prompt. You can simply type the code in the notepad and execute it from the command prompt. Okay. Anything? How to highlight the data points in the line plot. So you just use for which itself will be using the O as the option. I repeat, you will be using a O as the option, for which I think I have shown that. So O you'll be using, let me show you that. You just need to use the O, that's it. Where is it? Yeah. So yeah, something like this you have, right? Whenever you have this, so here you can use O. This is one option I'm saying. Like this, there are a lot many options in the pie chart. Not pie chart, Matplotlib, sorry. Where is it? I think it has stuck, my Jupyter has stuck, so let me restart it. So, but I think I have shown you that. So somewhere I have shown you that, yeah. Yeah, this is where I shown you, I think. See, like, for the inside the line chart. So if you want to highlight the points, so just make use of O right there. So it will become a scatter plot. So it can become scatter plot. See, even if you want to know even more, say, under this line no. So if you want to increase the line size, you have a line size. If you have a line size where you can increase and decrease the width of the line. So you can also increase and decrease, even in case of this points also. If you can make use of size where you can increase and decrease the size. You don't have to be always this much itself. You have a framework. This framework is there. No, that can also be varied. It has its own possibilities. It's not that only restricted way. Okay. If that is only the case, then I'll quickly go on to the further. Any other things? Okay, yeah, this I said. How to install Python and Jupyter? So as I mentioned at the beginning itself, so you can install the Jupyter just by using a simple way. I showed you, right? Yeah, this is what. Pip install notebook. Just you go for in the command prompt. You can install. It's not that difficult. I think I can go with the next one more data set I would like to show, which is very, very interesting. So which will let us take up IPL data set. IPL data set, from where you can download in essence from the Kaggle. So before I continue, can anyone of you let me know? Can I continue? Hello? Am I audible?
Yes, sir, you are audible.
Yeah, thank you, sir. Okay, so earlier as I mentioned, there are a lot many websites from where you can get the data set. So earlier I shown you with respect to this CS Dojo. So if you can search for the multiple this thing data sets. So now I would like to show you something which is the Kaggle, which is well known for the data sets. So what I will say, IPL data set I would like to download from the Kaggle. So I'll just say like this, IPL Kaggle data set. See, so complete data set from 2018 to 2020, I can get the complete data set from the Kaggle. You can also get from the IPL itself, but you can get it from the Kaggle easily, right? And here is the option. So where 22 MB of data which is available right here, which is completely related to the IPL, okay, which is well known, our own Indian Premier League, right? So I'm just downloading this. So once after I download the data set of the IPL, so what I'll do, I'll just go to the downloads and I'll take that, and where should I keep? I should keep in my current working directory. This is what my current working directory, and I'll extract that. right? So after I extract it, so I'll see there are two files you can observe, which is ball by ball values are available, which is you can observe it is a huge data. I'm not going to touch up that right now, which is ball by ball data. You can think of it, but I'll touch up on this, which is a match data. Instead of ball by ball data, I'll just touch up this match data, which is the IPL matches 2008 to 2020. So I'll keep it in my current working directory. So what I'll do, I'll just create a new, just say Python lab. I mean, it's a third lab. So it is lagging behind. Can anyone of you let me know how to hide this one? Because I'm not getting option. Is there a possibility or not to hide this? Yeah, I got it. Thank you. Okay, so here, otherwise I'll continue here itself, no problem. Okay, my data set is here. It is IPL matches 2008 to 2020. So what I'll do, I'll just open that. I'll say yum data because matches data, right? So is equal to pd dot read csv of matches dot csv, right? So when I open that in data, so it has a huge data. Can you believe it? So it has a huge data. Whenever it has a error anywhere, so it will not take you to the further because it is an interpreter. So all these are not compiled. Stuck somewhere. My computer is being stopped. Just give me a minute, not much. When I was showing the current working directory, my jitter has started. Yeah, thank you for your time. So now I'll just open the new one. Yeah, the lab key. Okay, yeah, I'll quickly go to the importing pandas as PD from Matplotlib import plot as P. Okay, so once after I have imported my whatever required. So even today I'll also be in this session I'll also be touching upon one more thing. So before that, so I'll just quickly open that match data match thing. So I'll set IPL matches. This is the file name. So let me copy that file name. Read CSV of .csv. Okay, this is EM data. Now you can observe this is the huge data. Can you believe? So there are 816 rows and 17 columns. So, but if I wish to get to know only the information about it. See, okay, let me highlight one more point here. When I get this data info, I want you to observe this clearly and say yum data info. Okay, now you can see there are these many columns are there, which is ID, city, data, player of the match, venue, neutral. Sir, there are like this. There are lot many things, but out of this, what I wish to tell you in the sense there are totally 816 elements or 816 rows. But here is one column which has only 19 elements, so rest all are empty. Okay, rest all are empty. So such kind of empty columns, don't keep it in your data set. When you keep more non-elements, which is more the null elements you have in your data set, so the kind of results you get will not be accurate. You will get very less accurate results. So try to remove this kind of items from your data set. How to remove? So it is we can drop that column by using a drop method. I repeat, you can drop that column by using a drop method. So you can say, so the name of the column you want to drop is method, because it has only 19 elements. I repeat, it has only 19 elements which you want to drop. So I'll drop it. Right, but is it possible to do directly in the sense? No, you so have to use access one. So that's where you'll be dropping it. Now you can see that method is being dropped. You say now simdata.info. So that is what that result. I mean, it's a result where it has a method is being dropped from your table, right? So now I wish to take up a few case studies. So say, for example, the case study one. So if I say case study one, if I say case study one. So for suppose, how many times each team has won? How many times each team has won? That's what winning percentage, I can say, winning rate. So if at all you have to get to know about that the data in the sense, so from all these things, so here is one option which is winner. I repeat, so this is the column which I have to target, is it not? I have to target this column, which is winner column from this table, because I want to find out what I want to find out how many times the each team has won. So in that case, I want to target this winner column. So as I want to deal with only that winner column right now, okay, so I'll just say temp data is equal to, okay. And one more thing, as you want to take up each column right now, as I mentioned earlier also, you first need to find out the type of the data elements. So how to find out this? Like this. So it is what that data is in the form of what? It is each individual data frame. I repeat, it is each individual data frame that file has. So I'll say temporary variable. I'll just store with PD. I'll create one more data frame. In that data frame, I'll be holding only the winner details. I repeat, I'll be holding only the winner details. So how to create that in a sense? Let me create in the form of a dictionary. Let me create in the form of a dictionary. I'll say winner, right? Winner. So whereas this is the key, value is nothing else. The value of the, it is nothing else than the column name. What is the column name here? It is the winner. It should be specific. So this is the column name, right? So I'm creating one more data frame. What is the name of the data frame? It is the temp. Temp is the data frame wherein I am creating the what? I'm creating the temp is the data frame. I am creating based on the winner column present in the young data, right? From there, I will be counting the number of times wins. That's what I'll say. Count wins. Count win. How many times it has? Winning. How many times it has? So see, based as I said, it is in the dictionary. Dictionary has two values, which is key value pair. This is the key and this is the value, right? From this value, I should find out. That's what you say, that value counts. I should say value counts. So based on that value counts only, I'll be finding out, and this let me print it. Now you can see, you can observe, my dear students. Sorry. You can observe, my dear. So you can observe right here. Mumbai Indians has won 120 times. Chennai Super Kings has won 106 times. So totally these many times each team has won for those many times. Okay, so how many times each team has won? That is what this data shows. Okay, okay, fine. You got to know how many times each team has won, but later now you can also think of, like, can you can you find out the each key separately? Okay, can you find out each key separately and plot it separately? That's the next point I mean to say. So if at all, if you want to find out each key separately and plot it separately, what I can do in the sense, I'll just take up this right now. I'll only take up this. I'm not going to print it now. So once after I find the count, which is how many times each team has won. Okay, how many times each team has won. Now I'll be preparing the labels. I'll say labels is equal to, so x of 0. I'll be using the for loop. Okay, I'll be using the for loop for x in count wins. Count wins, how many times the count win. That's what x in the count wins dot key. Because see, I hope you know that, because it is in the form of what, dictionary, which is the key value. This is the key, right? Those keys I need to find out. I need to extract those keys as well. So yes, how to find out that? So now I'll be displaying the labels. So I'll be displaying those labels. So what are those labels? Right. Series subject has no attribute key. Yeah. So in this particular thing, it is not key, it is a keys, and it is a method, not the variable. Now you can observe from this table, from this data frame, I said, so this is what the keys, which is the name of the team is the key, and how many times it has won is the values, right? So from that is what we extracted the keys, and we stored that into the labels. I repeat, we extracted the keys, which is the name of the teams, and we stored into the labels, right? So that's what we did now. And now once after, yes, once after we have the keys and the values, now let us go for plotting the graph. Okay, now let us go for plotting the graph. Whenever, as I wish to plot the graph, okay, as I wish to plot the graph, you can plot the graph based on, right? You can plot the graph, either it can be pie chart, you can plot anything. So if you wish to plot the pie chart itself, so I can say pie chart. So under the pie chart, so you can have a count wins, how many times count, how many times it has one over labels. These are the labels, right? So you can plot count win is how many times it has one, and this is the labels, right? So p dot show count win. Okay, count win is, I am using it as count underscore win. Okay, okay, what is happening, in under this count win, we are having the what floating data values. First we need to convert, right? First we need to convert to how we want. Okay, what we'll do, before we this is, yeah, before we actually plot the graph. So we'll say, we'll make use of two variables as bar dot x is equal to p dot subplot. We'll create one subplots. We'll create each separately, wherein let us provide the figure size. We'll provide the figure size as in the ratio of 10 is to 10 is to 10. Okay, we'll give the ratio of 10 is to 10. So that is for the bar and the x, and this what I will do, this I'll keep it in the keep it as ax, which is pi of count wins, and this count win is nothing else than the x-axis. Okay, count win is nothing else than the x-axis, and this is nothing else than the labels. Labels is nothing else, these are the labels, right? So whatever we will be using. Now again, still error, invalid syntax in the line 1. Okay, subplotting. Just give me a minute.
Hello.
Hello, sir. Am I audible?
Now you are audible, sir.
I don't know what has happened. So in between, I'm disconnected.
Okay, okay.
Hello, sir. I'm audible,
Yes, sir.
right?
Yes, you are audible.
Yeah, because that's what I'm saying. Like, I don't know what made I am disconnected. So
No problem, sir. Now you are audible.
Okay.
Sir, how much more time do you require?
How much ever you say that, sir? Then
Not like that. It depends on the participants, actually.
yeah, that's
Actually,
true.
we set the
So
session from 10 to 12. It's already 12
okay,
o'clock.
okay. Can I finish it in another 5 minutes, sir?
Okay, sir. Okay, thank you. Oh,
Okay. Yes, sir. Okay. I hope I'm audible to you all. So right here, instead of I supposed to use comma. So now you can observe. So this is what the number of teams who won for multiple times. So that's the pie chart what we got here. So if even per suppose if you want the percentage, which is not displayed here, right? If you want to display the percentage, so what need to be done in the sense, whenever will be displaying this x as win, count, win, and labels. So right here you need to give the percentage. I say that auto PCT is equal to percentage 0.1. It is after it's a, say for example 90.1, 92.2. So for that I'll be using this how many times how much percentage it has 1. So this is to justify the display the percentage of win. It is 0.1 f for the floating value, right? So if I is here double, it is single. 0.1 here. Okay. So you can observe right now with the percentages are displayed right here. So this gives the winning percentage. I repeat, winning percentages. So like this, you can do in any in the on the same data. So you can do any kind of operations, whatever you would like to do. So this is the winning percentage of each team. So per suppose quickly, if I wish to take you to the next, because till now I was talking about only Matplotlib. I repeat, till now I was talking about only Matplotlib. If you ask me to speak something about the Seaborn, okay, Seaborn. If so, for which I have to import the Seaborn. I'll say that import Seaborn as ESB. Just for a couple of minutes, I'll throw light on the Seaborn. Yeah, import Seaborn. So now once after the Seaborn is imported, for suppose for which case study I'll use for case, I'll say case study Case study 2. So for suppose if I want to find out most winning teams in eliminator. I hope you know what are those eliminator games. So in the eliminators, who has won most number of times. So if I want to find out that, then for which I am using the cborn instead of the matplotlib. I repeat, I'll be using the cborn. So I'll say sb dot so count lot. So from the data, what are the things I need to extract? Because from the table, this is the table. As usual, I have winner. Okay, but that winner based on the eliminator. So it is not displayed here. Let me display it here. There will be an eliminator, right? Based on in the eliminator. See, this is what eliminator matches. This is the eliminator column. So I need to take up this eliminator column and this winner column. I need to work on these two because my case study is what most number of times the team is win in the eliminators. So I need to work on these two columns, eliminator and the win. I repeat, I need to work on these two columns, which is eliminator and the winner. So that I'm going to touch up right now. Okay, two columns. Right, cborn of m data. So from that m data, first I'll be taking up the winner column. In that winner column, okay, in that winner column, what data I need, which is inner data. I need the eliminator data. Eliminator column also I'll be touching upon. If these are okay, if this data is equal to, because you can see in the eliminator it has only s and y or n. That's it. You can observe. You can only have n and y, something like this. See, y means that's the eliminator match. Okay, that is where it is y. For that I'll be taking the right. Okay, it has the same way as I mentioned. There should not be any null values. So it has a null values. So that null, if at all beginning I mentioned that if it is having null values, see like this, that should be removed. I hope at the beginning when I started this session, I told about this point. If your column has null values, then you can't have this. So that you have to remove those null values. Then only you can plot like this. That's the reason you are getting the error here, that it is having the null values, which is NA. That NA values should not be there. Then only you can work with it, which is NaN. So that's how. But this is how you can plot by using the cborn, which is sp, which I'm using here. Okay, even I had a couple of other examples and case studies, but due to time restriction time, okay, so I have to stop here. But if you have any queries, I can take up. I can't see Zoom here, sir. Am I audible?
Yes, sir, you're audible.
But I don't know why I can't see Zoom panel. I don't know whether I'm in the meeting or not at all.
But you are visible and audible, sir. As participants, one important announcement is there. Tomorrow, due to Moharram festival, session is not there, and we'll have the next session on Saturday. Please remember it. Tomorrow we don't have any session, so next and final session will be on Saturday. The feedback link is being posted in the chat box of Zoom as well as in the YouTube. Please fill it. And if you have any doubts, you can raise your hand or you can type in the chat box so that sir will answer all the questions.
Sir, any problem? Because I can't see my panel here, Zoom panel. Is there any possibility?
Actually, no, sir. It is visible for us, sir, actually.